Hello everyone, in today's video we're going to be taking a look at Boolean operators in Python. Now what a Boolean operator is it's basically going to be the result of some kind of logical statement. Something can be two different options. It can be true or it can be false. Now the reason that this is very helpful for us is when we get into conditionals a little later on, it's going to make it much simpler for us to be able to basically grab the value we need, quickly make a logical check, and then continue our program based on what it is. Now there's a lot of different operators here. So to keep this one simple, I'm going to go ahead and create a couple of really basic numbers here. So I'm going to go ahead and create num1 equals 5. I'm going to create num2 equals 10. Keep it nice and simple for us today. So we're going to go ahead and take a look at the results of several of these and kind of go over what different ones mean. So what I'm going to do is I'm going to say result equals is num1 equal to num2. Now, one of the things you'll see here is your brain will immediately actually print results here, just for being thorough. One of the things you'll observe here is num1 is one of our variables, a value of 5. You'll notice num2 is a value of 10, which you'll notice between them is this funky guy. It is an equal sign. Now, your brain is going, aha, that should be correct. No, that would say num1 becomes num2, result becomes num1. No, we can't do that. Equals asks equals sets. That's the way I always think about it. Are you asking or are you telling? So what we're saying here is num1 equal to num2? If it is, the variable result becomes a value of true. The variable of result would be false, of course, if it is false, and we know it is false. So if we were actually to run this, you will observe the fact that my little print statement down here says it is indeed false. That makes perfect sense because they are not the same number. Now, the nice thing about equals is it is a great way to test two values. For those of you who are Java fans, comparing strings and objects, you know how nightmarish that is. We don't have to deal with that in Python. That's actually kind of nice. We can compare two strings actually pretty accurately if we needed to. But again, we'll get to that a little later on. So that makes sense. So let's go ahead and try something a little different. False because not equal. So let's go ahead and create a new one. I'm going to say result equals num1, exclamation point equals num2. Print result. Now in Python, exclamation point asks, is it not equal to? So let's logic this out for a second here. Num1 is 5, num2 is 10. 5 and 10 are definitely not equal to each other. So this statement is true. As a matter of fact, if I run it, you'll observe the fact that it says true because the two statements are indeed, this is a true statement. Your brain is going, there's an equal sign, stop it. But it's okay because of the fact that this is a full true statement. These get a little more complicated. So this is true because they are not equal. I know your brain is going, what? Because they are not equal. Exactly. That's true because they're not equal. Makes sense. Confusing, but it makes sense. So now there are other options we have as well. Again, this is just going to be equal to or not equal to. We also have a whole gamut of greater than, less than, equal to's as well. So let's say result equals num1 greater than num2. Let's go ahead and print result. Now, if I run this code here, you'll observe that it is indeed false. And the reason it is a false statement is because I am asking, is number 1 greater than number 2? Now, if I look up here, I can see very clearly that number 1 is 5, and I can see number 2 is 10. 5 is not greater than 10. This is false because it is not greater than number 2. Makes sense. Now, if I wanted to, I could come in here and say result equals num1 less than num2. And if I printed the results here, we notice that this is going to be a true statement because we're asking, is num1 less than num2? So if I were to go run it again, you will see true. Now, this is true because num1 is less than num2. Nice and simple than that. Now, these are the absolute basic operators, are probably the ones you're going to be using most of the time operating, but there's actually a bunch of other ones that make our life a little bit simpler as well. So let's go ahead and make some room down here. I'm going to come down here and I'll make myself a couple new variables. I'll say float1 equals 50, 10, I'll 0.0, I'll say float2 equals, we'll be nice and mean here. I'll actually do 10.0 and then we'll do 5.0. I like that actually. There we go. You can see what I'm setting up here. And I'm going to ask myself a new question. I'm going to say result equals, is float1 equal to float, actually, I will do num1 here. Now your brain is going, they're not equal because this one has a decimal. This one does not have a decimal. Let's go ahead and run it and see what happens. What you'll observe is you get a true. Yes, because we do have a decimal here, that doesn't necessarily break it. This gets really challenging because if I have something like this and I run it, you will see I get a value of true, even though your brain is screaming at you right now saying, this is not the number 5. It's very close to the number 5. And honestly, if we're dealing with hand grenades, we're well within the range we need to be here. But it says true. We actually need another way to evaluate that if that's something that we need to deal with a little bit later on. But we'll leave float as 5.0 in this one. So what I'm going to do is I'm simply going to change my statement here. I'm going to ask, is float 1 greater than or equal to num1? Now we have to think this out carefully, because what I'm saying is 5.0 greater than or equal to 5? Work it out. The answer is true. That actually makes perfect sense. Now, the reason it makes perfect sense is because of the fact that the two numbers are equal to each other. Therefore, we know that it is greater than or equal to. Now, if I come up here to put this up to a 5.01, if I execute this code again, you will still get true because 5.01 is actually greater than 5. And now this is still a true statement. Now, if I wanted to go really goofy here and do 4.99 and run the code, you will notice it is going to say false. And the reason it is saying false here is because 4.99 is not greater than 5. And now you can see that actually works very well. False because 4.99 is not greater than 5, which is the value of num1. Now, as you can see, these are relatively simple to operate. We don't have to stress out too much about it. We're like, okay, numbers, this is pretty fun. This is pretty easy to do. There's no weirdness here. I get this. This isn't too bad. Where does this get messy? I'll show you where it gets messy. Let's go ahead and create two colors. I'm going to create a color string called red. And I'm going to create a color string. I'll call it color 1, color 2, just to keep it simple for us today. And I'll create another one called blue. I'll go use my result variable because polymorphism. Is red, color 1, greater than color 2? Print result. Now your brain is going, oh, okay, that hurts a little bit. But B comes before R. What does it do? In fact, it is indeed true. And you can see here that it doesn't do a very good job of basically figuring out which one of these colors are superior. As a matter of fact, your brain's probably sitting here going, well, color 1 comes after, I see what you did there. Yeah, we're looking at first letter here. So if I were to go less than and run this again, you will see it is false. And again, it comes back to this kind of an action that determines that. When you're doing comparisons like that, there are vastly safer ways to do it. A lot of times people sort a list and stuff like that, but just be mindful of it. Comparing strings, alphabetical. Just be careful with those. One time I had a student put out one of these kind of actions. And you're saying, of course, and you run the code and it makes sense, but it doesn't make sense because it doesn't make sense because it makes sense. So just be very, very mindful when you are comparing strings that it checks within the logic because this doesn't make sense. You can't say is rock bigger than scissors. It's less than. Just be very, very careful. Comparing strings, there are better ways to do it. I'm just putting this particular one in here as an example so you are aware. Now, there's other fun things that we can do, too, when we're working with Booleans here. So what I'm going to do is I'm going to go ahead and create a couple to Boolean. I'll call it Boolean logic. Boolean logic. So let's say I have a B1. I'm going to be lazy here. True. And I'll say B2 equals false. So one of the things I can do is I can say result equals B1 not B2. Your brain is immediately screaming at you, as is all of these things here, and it's going to be giving me a big angry message because basically we're trying to overload this. Some people see that not and they get really excited about it. Now, one of the cool things here is I can actually attach this. What the not command does is it flips the logic. You can't put not between things because it's not an operator. It flips it. So my result here is not B2. So if I were to actually print this real quick, and this is one of the cool things here, and this is one of the common uses of these, if I actually were to hit this, one of the things you'll see here is B2 is false, not B2 is also false. And again, that's kind of one of those things you have to be mindful of. It's going to basically be, I'm sorry, results. I meant to print 2. That makes no sense. If I run this now, you'll see it is now true because I've taken B2 and I have flipped its logic. Now, you have to be really, really careful with things like this because this can get very, very messy very, very quickly, especially when we start taking a look at compound operators, which is what we're going to be doing in a few moments. So just be mindful that people see that not sometimes and get excited about it, but it is not the same thing as not equal to. I could have put a not equal to in here, and I could also have done in parentheses and done an equal sign with it, which would be really, really messy, but it'll actually give us the exact same kind of things. So what I'm going to do now is I'm going to make things a little bit complicated. I'm going to say compound logic. 1, 2, 3, 4. Sometimes when we want to evaluate things, we want to be able to evaluate items based on multiple different specific choices. So for example, let's say we'll keep B1 here. We'll say B1 is true. We'll say S1 is car. And we'll say V1 is 10. Again, we'll keep it kind of simple here. So what if we wanted to be able to make a statement that involved several of these together in the same logical statement? So I'm going to say result equals. So we're going to check to see if B1 is true. So I'm going to go ahead and do parentheses, B1 equals true. Now I also want to evaluate something else. And I'm going to say and S1 equals car. Whoop, we should print the result. Now your brain, of course, takes a look at this and says, okay, slow down, Chief. B1 equals true. This is the first thing we're actually going to be evaluating. So if we look up here, B1 is true. So this statement is true. Over on this side, we see a thing that says S1, which is our S1 variable, our string, and we're saying, does it equal car? And now when we take a look at these two, we realize both of these components is together. Now the other thing you'll notice is between these, I attached this thing that says the word and. And means both of these must be true for this to be true. If I were to run this control, you will notice it says true there. And the reason it says true is because both of these statements are true. Now, if I came in here, for example, and I said bus for whatever reason, I've now broken this logical statement. I'm saying, is B1 equals true? This is true. Is S1 equal bus? This is false. If true and false is impossible because and requires both of these to be true. So if I were to run this command again, you will observe that and means everything has to be true in order for it to be working. And mean, actually I'll do lowercase, and means that everything must be true to be true. This is a very, very important point. And it's one of those things that people get confused with as they start getting complicated. So the next one we have, of course, is or. So I'm going to leave this one alone for now. Or means any must be true. So let's go ahead and do the same thing we did here. I'm actually just going to copy paste this because I'm going to be lazy. Equals, paste, and I'm going to change this to the word or. Or means either. That simply means to us that if either one of these is true, the entire statement will be true. So if I come down here to print my result, if I execute this code, I expect it to say true because at least one of these two is true. So now if I run this, you will see the fact that it is indeed true because even though this is false, this is true. As a matter of fact, Python goes one step further. It knows this is true, sees the word or, and immediately bails. And that's actually kind of a good thing. Now, you're probably sitting here going, this could probably start getting a little complicated. And the answer is yes, it can start getting complicated, which is why there is a specific order of operations inside of Python that you're going to have to follow to be very, very careful that you don't accidentally. Luckily for us, folks have done a really, really nice job of showing us the order of operations processed. It's actually basically the same as it is in other languages. You'll notice grouping, and then we're going to be dealing with unary. We're going to be dealing with your divisions, subtractions, your bit shift, your wises, your multiplications. And what you'll probably notice on this is all of our logical things, don't worry about these get complicated, are actually going to be evaluated later on. You'll notice or is actually evaluated after and. So we check the ands, then we check the ors, and then basically we're going to work our way down the other controls when we're actually going to be doing a very, very complicated little projects. And to give you an idea of how nasty these things can do, see if you can figure this one out. All right, you think you got it worked out. You have your little handy chart. Eat this one. So what you're going to have to do is you're going to have to figure out what is the result. We can be true or we can be false. It's actually a numerical result in this example here. You could see that our A is 4, our B is 2, our C is 3, and our D is 7. Now your brain is going, why would you do this to me? And again, I'll leave it up on the screen so that you can kind of work it out by hand. But one of the things you have to remember is just the order of ops. And there's a lot of little places that are nice little traps in this one. One of the things you'll notice here is that we have our exponentiation right there. We haven't talked about that one, but basically it means raise A to B. That one works pretty well. You also notice we've got some subtraction. We've also got a couple funky ones in here. We have negation in here. That's something that we didn't take a look at in the previous video. All that does is take the value and flip the sign. So that's exactly what that is. You've also got some of this in here. You've got a not in here. You've even got an incrementer in there just to make you absolutely miserable. So I'm leaving this one up on the screen to give you kind of an opportunity to sort of bang through it. This would be a good time to go ahead and press that pause button. And I guess I could tell you some amusing stories, but it'll be distracting. All right, you ready? You ready? Let's go ahead and press run. Yep, this one is going to be 1. That will be your end result on this particular operation. So if you need to, like I said, break it down one at a time. Again, you can basically come in here and get this great little guy in the parentheses, a minus b. You can start right away by saying this is going to be 2, and again, working your way through each one of these individual components. Now, fortunately for us in Python, most of our logical statements will never get this messy, but they will from time to time certainly be challenging to sort of evaluate. Whenever you get stuck, always bust out one of those little handy charts and work it through one statement at a time. So as you can see, Boolean operators are a critical component of Python. It's going to be tied into a lot of conditional and logics when we move on to loops and those things a little bit later on. Enjoy.